calculate the ampacity of wires in a duct bank underground, several factors must be considered. The goal is to determine if the conductors are adequately sized for the intended load. The first step involves determining the load current. In this scenario, the breaker rating is 1300 amps frame and 2000 amps trip. Assuming the breaker is appropriately sized, the load current will be close to its trip rated current, which is 2000 amps. The second step is to calculate the number of phase conductors. There are 5 sets of 3-500 MCM RHW cables plus 1-2/0 cable. This equates to 15 phase conductors, calculated by multiplying 5 sets by 3 conductors per phase. Also, there is 1 neutral conductor. The third step is to calculate the ampacity of a single phase conductor. The formula for this calculation is ampacity equals table ampacity times adjustment factors. To find the table ampacity, consult the appropriate table for 3-500 MCM RHW cable in a duct bank underground. According to the table, the ampacity is 360 amps. Next, determine the adjustment factors. There are several adjustment factors to consider, including the conductor temperature adjustment factor, the ambient temperature adjustment factor, and the grouping adjustment factor. For a 90°C conductor, the conductor temperature adjustment factor is 0.82. For an ambient temperature of 30°C, the ambient temperature adjustment factor is 1.0. For 5 conductors in a bundle, the grouping adjustment factor is 0.86. Now calculate the ampacity of a single phase conductor by multiplying the table ampacity by the adjustment factors. Ampacity equals 360 amps times 0.82 times 1.0 times 0.86, which equals 253.75 amps. The fourth and final step is to calculate the total ampacity. Divide the total load current by the ampacity of a single phase conductor. Total ampacity equals 2000 amps divided by 253.75 amps, which equals 7.88. Therefore, the ampacity of the wires is approximately 7.88 times the ampacity of a single phase conductor, which is 7.88 times 253.75 amps equals 2000.65 amps.